So data modeling, warehouse is providing three types of models like star schema,
Snowflake.
Snowflake schema, and galaxy schema.
Galaxy.
So if you take the first one, star schema, so maybe it looks something like this.
Mm-hmm.
Set of dimension tables and a fact
Mm-hmm.
table.
Yes.
But if observe in the previous class also, I gave the same structure and I
Yes.
told that it is a dimension model.
Yes.
So that means star schema is nothing but dimensional model.
Okay.
But every dimensional model need not be a star schema, may not be a star schema.
Mm-hmm.
Every star schema will be a dimension modeling, but every dimension modeling may not be star schema.
Okay.
That means if you follow some special rules on the dimensional model, then it will be called as a star schema.
Okay.
What is that means? For example, you're having a set of dimension tables. In general, when you say stable, there is a possibility that you can have a relationships between them, isn't it?
Yes.
But when it is a star schema, dimension should not communicate with another dimension. You are not allowed to bridge set of dimension tables to communicate one another directly. So if you
Okay.
follow that principle in the dimensional model, then it can be called as a star schema. Okay.
Okay.
So in a dimensional model, dimension should not communicate with another dimension We should not have a relationship with another dimension.
Yes.
Okay.
Okay.
That means each dimension is an individual table. It is having only relationship with the fact table. It
Yes.
should not communicate with another dimension.
Okay.
So between dimension and fact, it is a relationship is there. That means we can call that as a normalized tables. But between the dimension tables, we doesn't have any relationship. So the dimension can be called as denormalized dimensions. Okay.
Okay.
That means if fact is centrally located and surrounded by set of denormalized dimensions, then the structure is called as star schema. Clear?
Sorry. So, like denormalized dimensions means.
Means I'm saying indirectly like a dimension should not communicate with another dimension.
Okay. Okay. Okay.
Usually in the database, we'll have a tables with relationships.
Okay.
So if you have a relationship between the tables, usually we'll call that as a normalized database.
Okay.
Normalized tables. If
Okay.
any two tables are communicating, we'll call that as a normalized tables.
Okay.
So here we are having the tables with the communication, but between the dimension and the fact, but
Yes.
not between the dimensions.
Yes.
So there is a reason I'm saying they are denormalized dimension, because dimension is not communicating with another dimension. That is the reason I'm calling it is denormalized dimensions. Okay,
Okay. Okay.
just I'll give one model. What
Okay.
is a dimension model we have discussed. Similarly, I'll give in the form of star schema. Maybe in later I'll convert that into Snowflake schema.
Okay.
So for example, I'm having a table called as in customers, and I'm saying it is a dimension table. It
Mhm.
is consisting the fields like customer ID, customer name, customer type, customer address. It is one dimension table.
Okay.
Similarly, I'm having one more table called as the D underscore stores. It is consisting something called as a store ID, store name, store type, and a store address. Similarly, I'm having a set of dimension tables like D underscore products. This table is consisting something called as a product ID, product name, product subcategory ID, product subcategory, product category ID, product category. So there is a possibility a dimension table can have more than one key also. So here I
Yeah.
took the three keys.
Mhm.
Next, D underscore times table. It is consisting something called as in time ID, year, quarter, month. All these are the dimension tables. And centrally, I'm having one more table called as an F underscore sales. This is a fact table.
Mhm.
So it is consisting something called as a customer ID, product ID, time ID, store ID. All these are the foreign keys.
Yes.
Along with that, I'm having quantity sold, amount sold. For example, these are the tables I'm having. All the four dimensions are communicating with my fact table. So this type of relationship is called as, or this type of model is called as star schema.
Okay.
So here we are having four dimensions are there, but these dimensions are not communicating one and another.
Mhm.
So this structure can be called as star schema.
Yes.
Next, Snowflake schema. So what is this Snowflake schema? It is also nothing but dimensional model only, but you have to follow some special rules on that.
Okay.
So what is that special rule means? Here, a dimension can communicate with another dimension. It is allowed.
Okay.
So if any two dimensions are communicating one another, then that structure is called as Snowflake schema. So how many levels it can be there means that depends on your business requirement.
Yes.
Is it should be there for all the four sides dimensions, you should have a child table or master table means nothing like that. If any one dimension is communicating with another dimension, then it is a snowflake. It should, there is no requirement that all sides will have a relationship with the dimension tables, nothing like that. Okay.
Okay.
So in a dimensional model, if any dimension is communicating with another dimension, then the structure is called as snowflake schema. Or in another way, if fact is centrally located and surrounded by set of normalized tables, normalized dimensions, then the structure is called as snowflake schema. Clear?
Yes.
Now I'll try to take the same structure what we have represented as star schema, and I'll convert this as a snowflake. So here in the customer table, I'm having something. Okay, I'll make small change in my previous one also. For example, d underscore customers. It is consisting of customer ID, customer name, customer type. Along with that, for example, I'm having a location ID, and for example, something called as a region, country, and city.
Okay.
So this is the previous content. We are having denormalized dimensions here. This is a star schema.
Yes.
When it comes to the snowflake schema, we are saying it is normalized dimensions. So what I'm trying to do here is I'm having something called as a location ID,
Okay.
but other fields I'm not having here. They are present in
Okay.
separated table.
Mhm.
Something like d underscore locations. It is consisting something called as a location ID, region, country, and a city. Instead of maintaining the address within the customer table itself, I'm trying to maintain in a separate table.
Okay.
So location ID is a common column. With the help of that, you are making a relationship between the two tables.
Okay.
Similarly, I'm having some tables in this format.
One sec.
So products table is communicating with the subcategories table. Subcategories table is communicating with the categories table. Same way, times table may also be converted into set of tables, which is maintaining like one table only year data, one table is only for quarter related information, one table is related only for month related information, maybe week information, day information, hour information, something like that. Maybe set of tables can be created. So for customers and locations, you're having a relationship. Between products and subcategories, there is a relationship. Between subcategories and categories table, also you're having a relationship. So if you build the tables in this particular format, then this type of structure is called as Snowflake schema. Clear?
Yes.
So what the fact table consists usually? Fact table will consist foreign key fields of dimensions and measures. But in general, what we'll have in fact table means simply we'll see it consists measures.
Okay, measures.
But along with the measures, it consists keys also, but no need to mention. Simply we'll say usually as it consists measures.
Okay.
So in my table, what are the measures means quantity sold and amount sold are the measures. Remaining four, what we are in customer ID, product ID, time ID, store ID, they are foreign key fields or key columns to the fact table.
Okay.
So clear about star schema and snowflake schema.
Yes.
So which one is mostly used in the projects? Means most of the cases will use star schema.
Okay.
It is not mandatory, but most of the cases will use the star schema. Maybe in some special cases, you may go with snowflake schemas also. So in the project, it's
Okay.
not like we'll use only star, only snowflake. As a combination, we'll use both the things also.
Okay.
And the third one, galaxy schema. So I think we have discussed previously the Daedalus principles. So what is
Yeah.
the first principle?
Subject oriented.
Yes, subject oriented. What do you mean that subject oriented means? Complete
We will
subject
subjective.
related information should be stored in one place and it should not consist any unnecessary data. So for example, in a particular organization, who is designing this particular model means architect will develop these particular models. You may say as a solution provider also. He will design these
Okay.
particular structures, whether it is a star schema or a snowflake schemas.
Okay.
He will design means directly will not create the tables, he will document it and he will give it to the database team. Database team will create those tables.
Okay.
Clear?
Yes.
But even database has to be created by the database developers means he has to, those people has to receive the document provided by the architect. But architect, he cannot give it directly to the database developers. Before that, he has to cross check with the client. That means he has to show the model to the client, take the approval from the client. After the tooling that has to be constructed within the database. Clear?
Yes.
So we need an approval from the client. So in a particular organization, for example, management has designed some subject areas. For example, one subject, and this subject is consisting set of dimension tables. So here I'm representing in the form of star scheme, but it is not mandatory that it is a star scheme. It may be having a snowflake also, but I am not represented in the diagram. Okay.
Okay.
And for example, this is subject is something called as marketing. Similarly, architect has designed not only the marketing subject, it designed various other subjects also. So first one is the marketing, third one is for example sales, and the third one is marketing, for example.
Okay.
solution provider, or you may say as an architect. Designed 50 subject areas. She has designed nearly 50 subjects in that particular
Okay.
project.
Mhm.
Or I'll say project is consisting nearly 50 subject areas. I already mentioned this is developed with the database team, but database team will be working once it got approval from the solution provider. But when the solution provider can ask to create this table means the solution provider or the architect will show this document to the client side people. After getting the approval from the client side people only, these tables has to be created.
Okay.
So architect showed all these particular documentations to the client. Now client is studying each and every table. In this process, for example, the client noticed that particular table is there which is used again and again, which is designed again and again.
Mhm.
So total of 50 subject areas are there. Client noticed that nearly 30 subjects 30 subjects subject areas subjects or subject areas consisting d underscore items table. So there is a d underscore items nearly in 30 subject areas. The same table created again and again. Clear?
Yes.
So after observing this particular process, immediately the client questioned the architect. Why you have created 30 subject areas? Why can't you
Mhm.
work with a single subject area itself? Instead of creating 3 subjects or 4 subjects, keep all the tables in one subject area. Is it not possible?
No.
Why?
Let's see.
Here the client is saying why you have created d underscore items table again and again. Nearly 30 times it is repeating. And because of that unnecessarily space will be wasted. So don't work in this format. You try to create this table only in one subject area and you share with other subjects. Like that the client is suggesting.
Okay.
So what the architect has to do now?
To create a one table, put all 30 subject in there.
So maybe try to convince the client by trying to place this d underscore items table in each and every subject area. If client is
Mhm.
not at all accepting, then we try
Mhm.
to convince the client, but if it is not happen, then you have to go as
Mm.
per the client specifications, otherwise you'll cancel the project.
Okay.
So as per the client specifications, you try to work with try to remove this d underscore items table except in one subject area. Okay,
Okay.
so for example, I'm assuming that this is a d underscore items table. Similarly, this is a d underscore items table. It is also d underscore items table. So the client architect has designed in this way. So client noticed that there is a table, items table in each and every subject, like approximately 30 subjects. So he's suggesting that why you are creating the tables for multiple times, create table only one time and you share it to other modules.
Okay.
So as per the client specification, definitely it is possible to do that. But in the subject oriented, we have already studied that if you try to maintain in different subject areas the data, like the table in different locations, you want to establish a relation with other subject areas, means subject oriented principle will not allow. It is saying that complete subject information should be located in one place, isn't it?
Yes.
So try to convince the client by saying that you should follow within the same format only. Try to have this table separately.
Okay.
What is an advantage means you'll have better performance will be there if you maintain the table separately. You should not say that we are following the data rose principle. Instead of
Yeah.
saying like that, you try to say that for better performance purpose, try to create the table in this way. But for example, the client is not at all accepting, then you have to go as per the client specifications, isn't it?
Yes.
So what is the client is saying that try to create this table only one time and you share it to other subjects. So to follow that particular instruction, what I'm trying to do is I'm removing this d underscore items table from the sales subject. Same way, I'm removing d underscore items table from the marketing subject. After that, I'm trying to share the d underscore items table from marketing subject to the sales subject as well as to the marketing subject. Okay, the same table we are trying to use it into the sales subject as well as into the marketing subject by having a relationship. Instead of maintaining data separately, we are creating in one subject area and we are sharing to other subjects. Clear?
Yes.
So whenever you share the tables in this way, then that structure is called as galaxy schema.
Okay.
If a common dimension is shared across multiple subject areas, if a common dimension is across multiple subject areas, then the structure is called as galaxy schema. Clear about this?
Yes.
So whenever you are sharing a dimension table to other subject areas, then that particular structure is called as galaxy schema. But when you are sharing it to other subjects, you should not link it to another dimension. You should link only with the fact table.
Okay.
Now, whatever the dimension is shared across multiple subject areas, so what is the common dimension shared across multiple subject areas? That is called as what you will call okay, conformed dimension. So the dimension which is shared across multiple subject areas through the fact table is called as conformed dimension. Clear?
Yes.
That only that particular table is called as conformed dimension. individually each subject may be a star schema or it may be a snowflake schema.
Okay.
So this type of structure is called as galaxy schema. Clear?
Yes.
So it is about data modeling.
Mhm.
So in the work environment, which is the schemas we'll use, it means in general, all the three models will be there: star schema,
Mhm.
snowflake schema, and galaxy schema. But most of the subjects will be in the form of star schemas.
Okay.
But if you create the tables in this format, basically when you're having as a snowflake schema as in the form of levels, will have better accessibility because it is in the form of levels.
Mhm.
So master and child table, something like that. But if you 1 minute, 1 minute.
Sure.
This conference will now be recorded.
So all the three models will be there in the project, but most of the cases will have the star schema. But which is more advisable means we usually will say star schema.
Mhm.
But as per the reporting perspective, Snowflake is more advisable. As per the
Okay.
ETL process, star schema is more suitable.
Okay.
But even though a reporting requirement requires Snowflake schema, but most of the cases will design star schemas only. But how do you
Okay.
get the faster execution in the reporting process means we'll have a separate concept called as an creating of hierarchies. That means even though it is a denormalized dimension, within that we'll be creating hierarchies at the reporting level, which looks like a normalized because it is in the form of levels, like region. Under that you'll have sub-region. Under that you'll have country. Under that you'll have city. Instead of having as a separate columns, we will try to make as a levels of data so that you can read the data in faster way. Usually
Okay.
that hierarchies will create at the reporting level, but at the ETL process, you'll be using star schemas, most of the cases.
Oh, okay.
So this is about data modeling. Next concept, data warehouse strategies. There are two types of strategies called as top-down strategy. Second one, bottom-up strategy. So if you take the first one, top-down strategy, so usually you'll have compulsory star schema, snowflake, or something like that. But after that, we'll talk about strategy. But these strategies will talk about basically whether like you'll have subjects will be there, and there is a concept called as an enterprise warehouse. So which one has to be created first, which one is later, is explained with these strategies. Both the strategies says that you should have a subjects and you should have warehouse, a centralized warehouse or enterprise warehouse. But which one has to be created first, which one is second, that is explained with the help of these strategies.
Okay.
So top-down strategy. This strategy is defined by Inmon. Is a one database expert. So he defined this particular strategy called as top-down strategy. Strictly speaking, not top-down strategy, complete warehouse, data warehouse theory is introduced by this person only in Mon. So usually we'll call this person as the father of data warehouse.
Okay.
So he's basically is a database expert. What are the problems he's faced in the database? So to overcome that, he introduced the data warehouse. So this strategy can also be called as Inmon methodology. So what he is saying means, as per theory of Inmon, enterprise warehouse has to be created initially and later derive individual subjects from the enterprise warehouse. Clear?
Yes.
First of all, is asking to create the enterprise warehouse, later the small subjects. So if you take your business system as an operational system, this operational system is consisting, for example, three areas or three components.
Mhm.
One is finance related data. It is consisting sales related data, and it is consisting marketing related data. So at the business system, there is nothing like star schema, Snowflake. They are set of tables.
Yes.
So the complete information is maintained in one place. Now this person is saying that create the enterprise warehouse. And this enterprise warehouse should maintain all these finance, sales, marketing related data. So here you can have maybe a star schema, or maybe you can have a Snowflake schema. Galaxy schema will not present here because there is no individual subjects.
Mm-hmm.
So only a star or maybe a Snowflake. So this itself is main. Here it don't consider that only 4 dimensions will be there. You'll have n number of dimensions. I am representing only 4, but you'll have n number of dimensions.
Okay.
So it is consisting finance related data, sales related data, marketing related data. All the things will present. So this is called as an enterprise warehouse. But after that, he is asking to create individual subjects. Asking to create the individual subjects. That means you are separating the data. So maybe the first one is belonging to finance data. It is consisting only finance related details. Second one is consisting only sales related data. And third one is consisting only marketing related data. Now these subjects are depending on the enterprise warehouse. Until the enterprise warehouse is ready, you cannot create these subjects.
Yes.
So these are called as dependent subjects because they are depending on the warehouse. Clear?
Yes. Yes.
But in general, in the context of strategies or in the warehouse perspectives, instead of saying subjects, we'll use some other name here. What is that name means? We'll use a name called as a data mart.
Okay.
So we'll use a term called as data mart. So finance data mart, sales data mart, marketing data mart.
Okay.
General name is subject. Technically we'll call as data mart. So as a definition you want to say what is a data mart means, we will say it is a mini warehouse pertaining to particular subject area. So what is the data mart means? It is a mini warehouse pertaining to particular subject area.
Data.
Or maybe in another way, you can see it is a subset of enterprise warehouse. It is a small part of enterprise warehouse. Clear?
Yes.
So this is the theory defined by a person in Mon called as top-down strategy. Can also be called as an in-mon methodology.
Okay.
So next one, bottom-up strategy. Bottom-up strategy. This strategy is defined by Ralph Kimball. He is also a database expert.
Mm-hmm.
First of all, data warehouse theory is introduced by Inman, and within that particular theory, he came up with some changes.
Mm-hmm.
He asked to make some changes to improve the performance part or maybe maintenance part for all those things. He made some suggestions. So usually nowadays we'll call these two people has developed the warehouse, we'll say, but strictly speaking, Inman developed and Ralph Kimball made some changes in that theory.
Mm-hmm.
Okay. So this strategy is defined by this person. So many books are there by this person in the market.
Oh.
Ralph Kimball. So this strategy is all can also be called as Kimball methodology. Now what he is saying, it is like a reverse process. First of all, he says that create the subjects at the enterprise warehouse. So as per theory of Kimball, individual subjects has to be created initially and later integrate
Mm-hmm.
subjects to get an enterprise warehouse. Clear?
Yes.
Because when you create an enterprise warehouse means usually what it is a summarized data. You are summarizing all the subjects data. Once you have summarized it, then how can you give the detailed data individual subject wise? Not possible. To give the individual subjects, maybe in the enterprise warehouse, you have to maintain the complete data without doing the summarization. No meaning in that.
Yes.
So there is reason he's made some changes in such a way that first of all, is asking to create the subjects. Once the subjects are ready, then he is asking to create the enterprise warehouse. Something like this.
Okay.
But here, these subjects, they are not depending on the enterprise warehouse because they are created before that itself, isn't it?
Mm-hmm.
So usually we'll call them as a independent data marts. Okay.
Yes.
So usually in the work environment, which is the strategy you'll follow means most of the cases you'll follow bottom-up strategy. Almost
Okay.
all the projects will be there in the form of bottom-up strategy only. Okay.
Okay.
So this is what data row strategies. Next. Slowly changing dimensions. So already we studied about what is dimension object, what is a dimension column. In the
Mm-hmm.
similar way, there is a concept called as slowly changing dimensions. So in the ETL process, we'll be implementing this slowly changing dimensions.
Okay.
Usually we call as type 1, type 2, type 3 functionality, something like that. So as an ETL developer, you have to implement those features. The tables will be ready, but in this particular concept perspective, you have to load the data. So what are these slowly changing dimensions? We'll take it up in the next class. Okay.
Okay. Okay.
So for today, we'll close it here.
Okay. Thank you.
Thank you.